This video is talking about inverse functions. We've talked in previous videos about functions being one-to-one or not. If a function is one-to-one, then you can calculate its inverse function. Inverse functions, the notation is f to the minus 1 of x. This does not mean an exponent. This is just a notation that we use to refer to the inverse function. Functions g of x and f of x are inverse functions if and only if f of g of x equals x and g of f of x equals x. This is kind of the proof you can do to determine if functions are inverses or not. To find the inverse of a function, we replace f of x notation with the letter y. Interchange your x and y. In other words, you're going to interchange the domain and range of each function. Solve the equation for y. Replace y with the symbol f to the minus 1 of x. For example, if I have the function f of x equals 5x plus 3. If I want to find the inverse, we're going to first write the equation in x and y form. Y equals 5x plus 3. That's the first step. Second step, switch the variables or interchange the domain and range. Okay? So x equals 5y plus 3. Now solve the equation back for y. So I'm going to subtract 3 from both sides. So x minus 3 equals 5y. Divide both sides by the 5. So f to the minus 1 of x, or the inverse, is 1/5 x minus 3/5. Let's try this one. Same procedure. First step is write it in terms of y's and x's. Switch the variables. Now solve back for y. So I'm going to subtract 2 from both sides. I am going to multiply 3 by negative 4 now to get rid of, to get y by itself. So multiply 3 by negative 4. Okay, so f to the minus 1 of x, or the inverse function, will equal negative 4x plus 8. Find the inverse of the function f of x equals the square root of x minus 3 for x greater than or equal to 3. So they gave us the domain of it as well. Let's graph that in the coordinate plane we have here just for review purposes. We know the square root function is the half of the sideways parabola. So it would be 1-to-1. X minus 3 means we're going to shift it to the right 3. So let's see. This is the basic shape of the graph there. And the domain is true. X is greater than or equal to 3. But if we want to find the inverse, we're going to do the same steps that we did previously. We're going to write this in terms of x and y. So y equals the square root of x minus 3. Switch the variables. Now to solve this for y, to get rid of a square root, we're going to square both sides. So I have x squared equal to the square root of minus y minus 3 squared, which we know just gives us x squared, and when you square a radical, it goes away. So then add 3 to both sides. So the inverse is the graph x squared plus 3. Now, we cannot graph the entire portion because it's not 1-to-1. X squared plus 3 we know is the parabola that's been shifted up 3 units. So I'm going to just do the left-hand side because that really is what we're looking for. And if you notice, we need to restrict the domain of this. So I'm going to say x has got to be greater than or equal to 0. We only want the right-hand portion. You don't want the whole parabola because that would not be 1 to 1. But if you'll notice, in this coordinate plane we have here, you have the line y equals x plotted for you. If you notice, inverse functions have another characteristics. They are our reflection of each other across the line y equals x. This is the line y equals x. Notice that my inverses are a reflection across that line. Pretty neat. Let's do another one that way. Find the inverse of the function f of x equals x squared minus 2 for x greater than or equal to 0. So they've got a restricted domain here. We know that f of x equals x squared minus 2 is the parabola shifted down 2. Okay, there we go. That's that part of it. X greater than or equal to 0 means we're just going to talk about the right-hand side of it. So let's find its inverse. So we have y equal to x squared minus 2. Switch the variables. To solve back for y, I would add 2 to both sides. And to get y squared back to y, we take the square root of both sides. So x plus 2 equals y. There's my inverse function. We know that that is 2 to the left shift. You notice we have a reflection across the line y equals x. I need to write this f to the minus 1, which is the inverse, is to the square root of x plus 2. Now, one of the things I told you earlier was a proof that you can do to tell if two functions are inverses or not. F of g of x has to equal x, as well as g of f of x has to equal x. They both have to equal x. So let's see if we can prove if 3x and negative 1/3 x, let's see if they're inverses, yes or no. So if I do f of g of x, that's picking g and putting it back into f. So we'd have 3 times negative 1/3 x. If I multiply 3 times negative 1/3, I get negative 1x. So negative x. Therefore, I don't even need to go any further because the negative is breaking my rule here. It's got to equal just positive x. So no, they are not inverses.